Hello, let's start with our 8th section. We need a way to deploy and run our services, and nowadays there is an obvious choice. At the very beginning, we'll have a look how to run all of the services in Docker on our local machine. Then we check how we can use Docker Compose to build and run the services locally. And then we raise the bar and deploy the Docker containers in a real cloud-ready environment. Now we're adding Docker to the mix. We start by Dockerizing the bookmark service, as it is one of the more complex services, and then we start to see how this is applied to the other services as well. Maybe you have heard from it. You can use Docker to build the software itself and the Docker containers with only a subset of the generated files by using multistage builds. So you basically have two choices here. You either build your services with Maven and then as part of the Maven build or after the fact, create the Docker container, or you use multistage builds and do everything in Docker and generate a minimal Docker image that contains only the artifacts you need as last step. The first approach is something that first comes to mind because we know how to build stuff, so we solve the Docker thing afterwards. While this is not a wrong approach, you still have to make sure that your build is repeatable and that the servers you build your stuff on has all the right versions of Java, Maven, etc., so that may become an issue. With multi-stage builds, you can rely on a stable build environment. The builds are pretty much repeatable, with the exception of dependencies that are fetched from the web. But this can be solved by using our own Nexus on our Artifactory instance, for example, to provide a stable home for our external and internal dependencies. But if you do a lot of fancy stuff, for example, use Dockerize database in your integration test during the build, you might get more than a few gray hairs until everything works using multi-stage builds, and as such it looks complicated at first. To be honest, in the coming example I'm using the first approach as well, simply because the infrastructure requirements would be higher. For example, we would need to have a local Nexus as well to serve the base layout jar and to cache the dependencies, so the build images don't have to download half of Maven Central for each build. But for a long-term solution you should have a look at multi-stage builds. It's really worthwhile and it helps to keep the build server dumb and easy to replace. So as promised, we first have a look how to Dockerize our project. So welcome to our videos. First, I want to show you that I've created a few more commits in the repo, which you may want to have a look at because we're slowly going towards the end and I wanted to get rid of a few things and clean them up. And maybe you also learned something in the process, so I created a lot of small commits. So like, for example, a little bit of cleanup, fixed some tests which were broken during the recent commits. I also removed the Hystrix-based HTTP notification to the rating service. We only want to use the events here. I switched one of the tests for the bookmark service to use internal H2 database instead of the other database was used for the running service. And I also disabled the Eureka client there. I discovered that we still have some configuration regarding dates as timestamps, which is now false by default in Spring Boot 2, so we don't have to do that anymore. I removed the do-it-yourself call tracing because we added Sleuth and Zipkin, and it's much more capable than the stuff that we did, so let's get rid of it. In the bookmark service, we had the active profile detection to add, for example, the dev profile and the profile based on the username. And it looks like that broke during the Spring Boot 2 upgrade, and I only noticed it now. So I fixed that as well. And I removed the inframarker stuff from the services and simplified the build scripts, which I used heavily during the creation of this preparations. Alright, so to Dockerize we have to do a lot of typing, I mean really a lot, and I can't do that on video all the time. So we go slowly through these changes, and if you can type fast enough or you want to listen to me, just have a look at the GitHub repo. You don't have to type that yourself. It's pretty boring to do that for every service because it's pretty much the same all the time. Let's start with the POM file. Let's go down to the corresponding change. So in the each POM file, I set the final name always to service. This means that when we build it via Maven in /target, we get a service.jar. Otherwise, it's the artifact name.jar plus a version. And we don't want that because this makes it easier to create the Docker files. Because when every service is named service, we can just copy the Docker file around without any changes, which is a big benefit. And the jar name doesn't matter anyway because it's not deployed on a Nexus or something like that. It's just packaged in the Docker file, and the corresponding Docker file will get a better name. All right, and in the Docker file that I've created, I'm not sure if you have seen Docker files before. At the top you have a from, and then you have a base image. In our case, this is OpenJDK 8. We only need the runtime environment and not the complete JDK. And this is the one that is based on Alpine Linux version 3.8. Alpine is a little bit smaller than many of the other base images. That saves a little bit of storage. All right, then we use apk --update at curl because in one of the recent Docker updates, we got the possibility to add a health check, which means that Docker itself can recognize if a container is healthy or not, and for example restart it, or it will just print out if it's healthy or not in the overview. So this is very nice, and many of the other Docker-based management systems like Rancher, etc. also check these health checks for health information, which is very nice. And then we always do this, copy target service jar to a location in the Docker file. Doesn't matter where, this is just a nice location, user app. And we do this basically every service. Then we say, okay, we expose port 8080 for regular work and 5 ones for the actuator stuff. The big advantage is that we can now lift the burden of authentication from the actuator stuff because on port 8080 you won't be able to access it. And this port will only be reachable inside. So it's not perfect security, but it's okay-ish for the most part, and especially for the start. So we don't need any authentication for the actuator stuff. Then I'll always define some kind of environment here and default to local, which means that when you start the Docker container, you can override the environment if you like. This enables us to have, for example, local development and then staging and live deployment, etc. And we just have to provide the environment variable, the correct value, and then we use it as profile here. But we come to this in a minute. So then we have the entry point, which is what happens when the Docker container starts. And we just say Java, which is found using the path that is defined inside of the image. And then we say, okay, please prefer the IPv4 stack. This is something that I've experienced myself in my other projects. Sometimes Java uses IPv6, and then I had pretty weird connection issues. So I switched to IPv4 here. You can try to omit this. I had some problems. You can check this out for yourself. Then we have these two because they belong together. First we have to say, okay, please unlock the experimental VM options, which is required because what we're using here is OpenJDK 8 still experimental, and I think in 9 or 10 it's also accessible without this. And here we say, okay, please use the C group memory limit for, which means that if we don't do that, the Docker containers take up too much memory and we can't limit it correctly, which is bad because if you want to start up 20 containers, for example, and everyone thinks, oh great, I can take almost all of this 4 gigabytes of memory, for example, that are available, then you won't be happy because you will get out of memory exceptions. And then we say -jar and start up the jar file. That's pretty straightforward. And here is a little bit of configuration for Spring. So we say the active profiles is always Docker. I put it at the end so the environment can override whatever is in here. And I always configure here the Spring Cloud config URI to use config server. Because whatever we do, we should make sure that the config server is accessible using this DNS name. So this was the Docker file, and basically all other Docker files will look the same, as we will see. Next is the security config. I just removed the any role admin stuff for actuator. and set permit all. And I also removed the user detailed service stuff that we added here for the admin service. So in our application YAML, that's basically the same here. I didn't change anything here. I removed the Rika instance metadata map stuff because this corresponds to the security user detailed service. And we don't need that anymore for the admin service. And in Bootstrap YAML, I added something that I should have added before, but I did it during the preparations. So in Spring Cloud Config, you can say fail fast true, which means that when the service is not able to reach the config service, it will stop, which is very important because when the service tries to start before the configuration service is up, it needs to fail as long as the config service is not here. Next is the retry. So I say, please use that 60 times. So we give it some time. And we also say, okay, please don't use discovery, but this is not that important. All right. So this was the bookmark service. Let's have a quick look at the admin service and do the rest in the next video. So you will see that I just set the service name here. The Docker file is basically the same that we had before. Oh yeah, I see, I added a remark here. There is a different entry point variant too, which uses square brackets. Don't use that if you use an environment variable here. This doesn't work. It will not be resolved, so we'll always have $environment here. Please learn from my mistakes and use this format. And otherwise we just have this here. And that's all that what we had to do for the admin service.